Welcome to today's presentation. Today we'll be talking on the risk rating and assessment. My name is John Bwadamuma, and I'll be your facilitator in this particular lesson. So, as you may be aware, that risk is an important aspect of almost every business undertaking or project. So whenever you are engaged in a project or an operation, you find that inevitably there will be some aspect of risk, either is in the business investments or food safety. You find that risk is almost inevitably present. But in food safety, when we talk about risk, we're talking about the likelihood that if a person consumes a particular food item, that they will not get harmed by that food item. And so in this context, when we talk about risk, we say risk is the likelihood that when a person consumes food, they will not be harmed. So it has two components. It has the aspect of the likelihood of occurrence and the magnitude of the consequences. So these two aspects are very, very important. And you see that assessing risk of the potential hazards helps us to determine in making choices. For instance, if you want, for instance, to import milk or beef from one particular country or region of the country, and then you have to look at what are the likely dangers or the potential hazards that can come with milk from those different sources. And now for you to prioritize which one is likely to be the safer milk, and so that you can make a decision, you have to do some form of risk assessment. And in so doing, you need to rate the risk. You need to rate the risk so that you know which one is a higher risk and which product has got a lower risk. So that's what we talk about the risk rating. So in that case, you have some form of scaling where you can use, which can be used in order to make choices. And this is very important, not only in making choices, but also with respect to prioritizing intervention measures. For instance, if you have different suppliers who supply you commodities to your enterprise, and then you do some form of risk assessment, and you find that, for instance, the risk of a supplier giving you a contaminated product, maybe supplier A is higher than supplier B. Now, but you might need the commodity from the two sources. So what you do is that you may want to put in intervention measures in order to reduce the risk. So now this risk assessment helps you to prioritize where to put those intervention measures so that you can have reduced the risk. So in this lesson, we'll focus basically on rating risk using the probability of occurrence and also the consequences, the severity of the consequences. So these two elements are what defines a risk. So we're saying that risk is a function of the probability of occurrence or the severity of the consequences. Because risk identification and rating establishes priority, this assessment should be incorporated early in the analysis. So when you are doing risk analysis, we're talking about you need to prioritize in terms of which has the highest risk and low risk. So we are saying that the aspect of rating the risk should be put in place early in your analysis. In other words, if you have a risk analysis framework, you have developed the methodology, that methodology should incorporate how risk rating will be done. And so in this particular lesson, we'll learn how we can do that rating of the risk. So a higher degree of risk assessor training is required. So, for you to be consistent in terms of rating the risk, you need to have some form of training so that you can be consistent in terms of how you rate risk in different situations. If you don't have, if you're not well trained, or you don't have experience, you'll be very subjective, and you'll be allocating rates, much more on a arbitrary scale. But with experience and the adequate training, it calibrates, your skills are calibrated so that you can, do a better job in terms of assessing risk, which is very, very important, as it will help us to prioritize, for instance, where we need to put intervention measures, also in decision making with respect to where the sources we could quote commodities if we are in the procurement business. So applying control measures will be very, very important. If you want to apply control measures, as I said, you target those control measures to those situations where you determine risk is very high, so that you can reduce the risk. So in this lesson, I would want you to be able to define probability of occurrence. At the end of this lesson, you should be able to define probability of occurrence, and also be able to define what the severity of the consequences is, and also then be able to calculate risk using the probability of occurrence and the severity of occurrence, both using the linear scale and also using the weighted scale. With respect to food safety, we have the risk assessment with respect to chemical risk assessment, and also we have got a risk assessment related to microbiological. But we can also, the chemical one, if you like, we can partition it to the chemical related to food additives and also pesticides. So we can have food additives, and then also we have a pesticide risk assessment. Those, if you like, is for under chemical, but then we have also microbiological risk assessment. So this will come back in details to explain when we talk about the severity of the consequences. So when you follow the pathway for microbiological risk assessment, there's a way in which we assess severity of the consequences, and also the toxicological, or the chemical risk assessment or pesticide risk assessment. Also, there's a way in which the severity of the consequences are estimated. But all in all, what we are saying that the probability risk is a function of the likelihood of occurrence of an wanted event, and also the magnitude of the consequences. Okay? So how do we go about quantifying the probability of occurrence and also severity of the consequences? So many risk assessments use this methodology where you use the probability of occurrence and the severity of the consequences in order to rate the risk that is associated with the exposure to a particular hazard. In this case, we are talking about food safety hazards, chemical or biological or physical hazards. So if we are to look at the formula for this particular risk quantification, we are saying that the likelihood risk rating, which is, as you can see in the bottom line there, it says risk rating with RR is equal to the probability of occurrence, which is PO, multiplied by the severity of consequences. So that's what gives us the risk rating. So you have two, it's a product, the risk rating is a product of those two variables. So probability of occurrence explores the likelihood that an identified risk risk will occur. In other words, it occurs that an identified hazard, I think the better word to use, hazard will occur. For instance, if say for instance, we are talking about the risk that a person will be exposed to, let's say, pesticide in milk. So we're talking about what is the likelihood that pesticide will be present in milk at the time that it was being served, to a consumer. So probability of occurrence talks about the likelihood that a particular hazard will be found in a particular food commodity at the point that a person will be exposed. So when we are using risk rating, you can rate the risk from not present to present. So we can use a scale, if you like, if we are using the qualitative approach. So for quantitative risk assessment, the likelihood of occurrence can either be 0, that's a minimum, and the maximum will be 1. And of course, in between there, you have got different possibilities when you're using the quantitative approach. And of course, you know that if you use the stochastic approach, you find that at each of those points, you'll have the distribution. But that is a discussion for another day. What we want to talk about mainly here will focus on the qualitative approach. But if you are using the deterministic approach, deterministic, which means the point estimation in terms of risk estimating, if you take the point 0, that is no risk, to the 1, that's the risk is present. And in between, you have got, you can have 0.1, for instance, or 0.2, 0.9, up to 1, that's a maximum. Then it's obvious that the risk is present. And that's on a deterministic scale. But I think in the lectures that will come, we'll talk about the stochastic approach to modeling risk. Now, when you come to using the qualitative approach, and in this case, we put the risk on the scale so we can quantify and say present, not present is 0, then almost certain that the hazard is present, that is 4. And in between, we can have 1 is rare, and 2 is common, and then 4 is almost certain is there. So we can use that. Let me give an example, for instance, talking about E. coli in milk. In milk production, you may find E. coli, and E. coli is a common contaminant in milk. So if we are to look at the likelihood that E. coli will be found in milk, it's almost certain. So in that case, it will fall under the rating of 4. It's almost certain E. coli will be present. So on the linear scaling, in that case, the likelihood that E. coli will be present will be 4. Now, if you turn to other pathogens that are rarely found in milk, because of course, if they are present, they pose quite a lot of danger. So if you look at Brucella is a zoonotic pathogen that is found in milk, and human beings can suffer from this disease called brucellosis. And if the people have got this brucellosis, they have a condition which brings about undulant fever and many other challenges that go with this pathogen. It's a chronic disease. Brucella pathogen causes chronic infection. So the animals can be infected with the Brucella pathogen, and they can shed the pathogen into milk, and human beings are likely to be exposed to that Brucella pathogen. But in a herd which is well managed, where there are proper control measures, they do the vaccination, and also herd management is in place, you find that the likelihood that Brucella pathogen will be present in the milk is very low. In that case, you find that we can classify on this scale that it is 1. In other case, we are saying it's almost rare, if you want to say. Taking in mind that we are talking about 0 not present, and 4 we are almost certain that it will be present. So for E. coli, we are saying that we are almost certain that the pathogen is present. But for Brucella, we are saying that this is very rare, because the nature of the hazard itself implies that the farmer puts in measures to take care of this particular hazard. Now let's look at this scaling based on the standard linear scaling. So as I said, that if you can see on the extreme left, we're talking about rating, the likelihood of occurrence, the occurrence value. So we have got not present, which is 0, rare 1, possible that it is there is 2, and then likely 3, and almost certain is 4. We are using the Rickert scale, if you see there, and then we can attach percentages in case you want to relate this to quantitative values. So we are saying that present not present is 0. Then anything ranging from 1 to 10 is rare. And then we can also classify 10 to 50 that it's possible, and then 50 to 90 is likely, and 90 to 100 is certain that the present is. So you can use this categorization in order to come with your rating of the likelihood of occurrence. Okay, then we put, of course, the descriptors. They are there. So the other factor or element that is essential in determining risk is the magnitude of the consequences. The impact that this particular hazard will have on human health, and also not only human health, but also on the resources, or either the company or the economy of the nation, and also the property or even the reputation of the company. For instance, imagine that you are in the food safety industry, you have a business, and then you happen to have, say, for instance, your food is contaminated with, let's say, for instance, for the sake of it, let's say cholera, and then people get sick as a result of consuming food from your restaurant or your business house, and then they get sick. So the consequence, of course, is that it will have effect on their health, and people may even die as a result of consuming, taking this particular hazard, being exposed to this particular hazard. But also, if this particular hazard, there was an outbreak of cholera on a larger scale, it will fact that it will affect even the resources, because the government will have to commit resources to control the outbreak, and the people will stop going for work, and so you find that the government may put measures to control cholera and other things, so that will impact on the economy of a nation or a region. And of course, there are other risks that may affect your reputation, for instance. If say, for instance, Zambia has an outbreak, and in Lusaka there's cholera, if tourists comes, they'll say, oh, in Lusaka there's cholera, that place is a dirty place. Or if you're a restaurant, people come here and they suffer from salmonellosis or campylobacteriosis, they eat food and they get sick, and they'll say, oh, that place is a hopeless place. I went there and I suffered from diarrhea, and I was vomiting and other things. Don't go there and eat food from there. So it destroy your reputation. So those are the consequences, which can lead actually to a loss of business, or even sometimes can lead to litigation, and also even closure of your company. And so those are the magnitude of the consequences that when we are looking at risk, we look at those aspects, the likelihood of occurrence of the hazard, and also the magnitude of the consequences. So we can also rate this magnitude of the consequences on this scale. On the Rickert scale, we can say, for instance, no impact or no consequence, no impact, to high impact. So we can say no impact, for instance, 0, and then high impact, we put a value 4. Okay? And then in between, you have got a minimum impact, moderate impact, and very high impact. So that's the way you can look at this. Let's look at an example of, so for instance, if the same case that I talked about, E. coli in milk, if say we talk about somebody consumes milk and it has E. coli, you know that in most cases, except for those rare pathogenic strains like the O157H E. coli pathogens, which are pathogenic, but in most cases you find that E. coli is a normal contaminant. It's a normal flora, such that even if it's present in the milk and it's not controlled, people may consume it and they will not get sick. Yeah. So in most cases, E. coli is a normal contaminant, and you may have it. The likelihood of that E. coli will be there will be very high, but the magnitude of the consequences may be close to 0, or the impact it will cause on health as a result of the failure in the control systems, it will be almost 0. Whereas on the other hand, brucellosis, the magnitude of the consequences are very high. Yeah, it's very rare to find in milk, but if it occurred, people are likely to get severe consequences, or the impact will be very high. Somebody will be chronically sick, will have undulant fever, chronic fever, and also it causes things like arthritis and many other complications which are caused by Brucella. And so failure as a result of controlling this pathogen may lead to, misery, untold misery to human health. So although it's rare, but we find that the consequences will be high. In that case, we'll put it in a classification as a high impact hazard. Okay? So this severity of consequences with the RINIA standard, if we now look at it, can result either in high impact and resulting in destroying reputation, or low impact depending upon how the classification is with respect to the hazard. Now look at this. These are the scales for the consequences using a RINIA scale. On the extreme left, you find the rating of the consequences, which is no risk, in fact, no impact, minor impact, moderate, and high. In fact, the best is impact. And the value, there we have got 1, 2, 3, 4. 1 means minimum impact, and then 2 minor, 3 moderate, and then high. And then we look at the different types of impact value things that can be affected in terms of impact. We're talking about human health, resources, work performance, property, or reputation. So we can put those as you can see that, for instance, if we are saying that no impact in terms of human health, then you say it has got no harm. And the minimum impact, it has minor harm. Then moderate, it has moderate to life impacting harm. Then if you say high impact, then which or high consequences, we are saying this is life-threatening harm from a single exposure. Okay, and similarly, we can talk about resources to the economy. No impact to the economy, moderate impact. You may need additional resources required to control it, and then also you may need to commit institutional resources required, or it may be at country level. Work performance, sometimes you find that these risks or these hazards may affect the work performance. For instance, a person may be hospitalized, or the abat or the restaurant may be closed, or you may need to close and start cleaning up and the other things, and so it may bring about disruptions. Either you can have minor disruptions or major disruptions, depending upon what has occurred in that particular. And then damage to property. Some hazards may actually result to damage to property, especially chemical hazards may result in damage to property. That if you allowed it to go through the system, and that it may actually destroy maybe some sensitive equipment or otherwise. And then I talked about the reputation. You can have no impact on reputation, or you can have, people can lose confidence in your business undertakings. So this is about the RINIA scaling. So the primary goal of risk rating is, of course, to differentiate between an operation with high risk and also low risk, so that it can help us to quantify or choose which is the best option among the many choices that may be confronting you. Now, if you look at the cases that I've presented before you, we have the E. coli, which has the high likelihood of occurrence. In that case, we can rate it as 4, but the consequences is 1. And then if you look at the formula that I gave you earlier on in terms of risk rating, so if you look at in the case of E. coli, it has the likelihood of occurrence is 4, but the magnitude or the severity of the consequence is 1. So if you multiply 4 by 1, you get 4. But also, let's come back to the Brucella situation. The Brucella situation, the likelihood of occurrence is 1, but the magnitude of consequence is high, is 4. It causes harm or life-threatening harm to human beings. So if you multiply that, it also gives you 4. So, when you look at that, sometimes you may want to remodel your risk rating because, even if the risk of you being exposed to E. coli is 4, and that of being exposed to the risk of you being exposed to brucellosis is 4. You know, the two risks may not be the same. So what you may want to do is to put some bit of weighting in terms of the consequences, so that those hazards which have low likelihood of exposure, but if they occurred, the magnitude of the consequence is high, you may want to differentiate the risk. So you may want to rate the risk. Instead of using the linear rating, you may want to put some weighting to it, just to differentiate. This is what I've been talking about. Example using the linear scaling, an activity with a certainty of 4 with no risk 1 would produce an overall risk of 4. Let's say, for instance, this is in terms of E. coli. E. coli, we say that it has a certainty of 4, but when you talk about the impact, it's 1, and then you multiply the risk rating, then it becomes 4. And also you come back to brucellosis. Brucellosis has the likelihood of occurrence of 1, it was rare, but the potential lethal consequences are very high, so 4. That also gives you the risk rating of 4. And we're saying that depending upon our priority in our establishment, we may say, we don't think this is the same. We don't, although this kind of calculation gives us equal rating for Brucella and E. coli, we want to put weight on those hazards which have got, increased consequences. So you may want to wait so that with that weighting, we'll be able to differentiate between the effect or the consequences of brought about by Brucella and those that are brought about by E. coli. So the weighted consequences value scale are what we are going to talk about now, and they reflect that you have embedded into that rating the consequences where you put more weight on those risks or those hazards which have got high consequences on human health, and you don't rate the same as those that have got minimum consequences. So this is an example now where we do the weighted consequences. You see, if you look at the second column where I put the value, in the linear rating, we had 1, 2, 3, 4. That's a linear rating, whereby if you remember what I showed, no risk, it was 1, minor, it was 2, moderate, it was 3, and high, it was 4. But we put some weight. We said this is not the same. We are going to rate the risk. If it's not present, if no risk, we put 1. Minor, 5. Moderate, 10. And if it's high, we put 20. So you see that we have weighted the risk, not just using the linear scale, such that now, if we are to go back now and estimate the same thing that we did for brucellosis, now let us look for, in this case, in case of the weighted consequence values, if the likelihood of an item, an event occurring is 4, with no consequence 1, we still get the risk rating of 4. But for an activity with a rare likelihood of occurrence 1, with a potential lethal consequence, in this case it will be 20, and the resulting consequence will be what? Will be 20. So in this way now, it becomes easy for us to differentiate the risk that is likely to be caused by E. coli and also the ones that is likely to cause by Brucella, because we believe that although Brucella is the likelihood of Brucella occurring is very low, but we put more weight on the consequences such that it ranks higher than the risk resulting from exposure to E. coli. So these priorities may be determined depending upon an institution or the company, the way they perceive risk, and of course the way they evaluate the consequences that may result as a result of the occurrence of that particular hazard in their food commodities. So what have we been talking about? We've been talking about how we estimate risk. We are saying that risk is a function of two elements. It's a function of the likelihood of occurrence and also the severity of the consequences. And we say that we can estimate risk using either the linear scale, or we can also estimate the risk using the weighted consequence value. In any case, you can use the Likert scales, where you classify your hazards, your likelihood of occurrence. In this case, we rate it either on a linear scale. It can be 1, 2, 3, 4, with the no likelihood of occurrence, or rare, or moderate, or high. And also the consequences, you can also break them and categorize the consequence with high impact, low impact, minimum, high impact, low impact. Sorry, you start with no impact, rare impact, moderate impact, and very high impact. And then you can also then multiply those. We'll look at, when we come to quantitative risk assessment, we'll also look at the matrices that are used to combine those. For instance, if you say, okay, I have got moderate impact, as I said, and then multiply by moderate what you get, we'll look at all those in this coming lecture. But of course, I think you understand now we rate this in terms of using this Likert scaling. And we are saying that each company or each enterprise can look at how they prioritize the risks, and also what resources are available to put measures in order to reduce the likelihood of occurrence. Thank you for listening.